東電会社のエネルギー経済局長でいらっしゃいます。ドイツのエネルギー大転換、皆様ももちろんご存知と思いますが、世界で最も
I'm sure all of you would know about the Energiewende in Germany, and I'm sure Dr. Klaus von Sengbusch will be talking about how Germany was able to push forward with the energy grand transformation, and it's one of the biggest TSOs in Germany and has the highest level of wind power amongst the TSOs. So he was also involved in the system reform, transformation, and I'm sure he'll be talking about what sort of function Renewable. Please.
Welcome from my side, and first thanks for giving me the opportunity to speak here. I think it's really an exciting thing to think how we can organize our future of electricity system, and we have reached a point where really some important decisions for the future have to be made in the next years. Now, I am not so familiar with the Japanese situation, but I learned a bit already in the last days when I was here, and therefore I would like to briefly say a few words regarding the general situation before I enter into my slides, comparing the German and the Japanese system. Now, I'm an electrical engineer, and I must say I'm personally convinced that engineers will be able to solve the technical problems that we will face when building up a CO2 low emission system, no matter if we do it based on nuclear or renewables. So I'm not one of the people saying nuclear is the wrong decision. I would even go so far and say I'm not sure if it was a good idea of Germany to shut down or to immediately after the Fukushima accident the nuclear power plants and partly replace these power plants by coal-fired units. But I think there is one very big difference regarding the characteristics of the problems that we face when looking at nuclear and looking at renewables. Now, if we take the problems that we have with nuclear, the characteristics is, from my point of view, that the main problems have to be solved in the future. At least that's a German view on the nuclear problems. It's a problem how to deal with the nuclear waste, which is unsolved today, and of course also in case of accidents, of nuclear accidents, how to deal with the situation, as you have much more experience compared to us. Now, the situation on the renewables is a bit different. There, all the problems that also exist, they have to be solved today. This is, I think, the situation. So it's not a simple path to say, okay, we shift to a system based on renewables. It's a complex step, but really the most complex problems have to be solved today. And if we manage to solve the problems, then our children can decide again how they want to produce their energy. I mean, it's very simple to tear down our windmills after a few years and do something else. With other options, this is much, much more difficult. And now the public perception in Germany, as I mentioned, is that, okay, the future problems are not solved with nuclear. And there's also, I would say, a lack of belief, of trust that people are really honest when discussing the problems. Now, at least in Germany, we have had some nuclear managers from the nuclear industry saying in the television, it's very safe to store nuclear waste in salt mines. They already exist for 10,000 years. It's really no problem. And we decided to throw some of our nuclear waste into a salt mine, and the nuclear manager said, it's safe, thousands of years. And it took, I think, 20 years, and some water went into that salt mine. And now we pay hundreds of millions of euros to dig out all this nuclear waste again. It's really a matter of trust if really people can be convinced that there will be solutions. And that's why I think in Germany the public more or less has decided no, they don't want to head for nuclear, and if they still want to head for a CO2 low emission system, then renewables seem to be the best option today. But of course, there is no free lunch. There are a lot of problems to be solved. Now, in case the politics say, yes, we want to fulfill the wish of our voters and we want to head for renewables. Now, what are the steps to take? And I understood somehow that this is also a discussion in Japan now, although I'm not 100% sure if there's really the decision was made yet so clear. But in case it really is made, and you really think, what can we do to get a smooth integration of renewables? I must say one big lesson that we learned is that you really have to take the questions of system integration very, very serious. Now, what does that mean? It means that nearly all decisions that you take have significant influence on the complete electricity system. And I think to bring this down to earth, what actually is very important, that you really get a large group of experts, of expertise, of best expertise in the country regarding the energy system to think about impacts of the change, to think how to overcome the challenges that are there. That's the positive thing is that a lot of problems can be overcome, and if you really accept that challenge, I think the solutions are available. Not all are known yet, but I think they will be found and the path can be followed. And it's interesting how actually I think Germany managed to build up such a group of experts advising politics. And there's a process now established where these experts come together regularly at different platforms. And it's also interesting to see who these experts are. In the very beginning of the liberalization process, nearly all the experts on electricity systems were located in the utilities, in the big utilities. And there, of course, such a process was very difficult to moderate. But now we have the situation that we have some very good consultants bringing their expertise in. Of course, we have universities, we have research centers, but we have also organizations very similar to the Japan Renewable Foundation. In Germany, it's called Agora Energiewende. That are doing many studies and bringing in expertise in the discussion process. We have one last group, and that's the TSOs. The TSOs are also heavily involved in the discussion. Now, why is this the case? Now, basically, TSOs are private-owned companies. So, of course, their business model is to earn money. But the way Germany set up the task for a TSO, or the way they can maximize income, leads to very similar aims for the TSOs as the politics. And therefore, the TSOs are a quite important advisor for politics in our times now, as they, on the one hand, benefit from the renewables, as renewables cause need for more grid assets. That's the main business model. But on the other hand, being also responsible for system security. That means if we would just allow all renewables to enter the system will probably fail, and this would destroy our business model. So that's a very similar aim the TSOs have, and therefore they are quite well accepted as a partner in the Energiewende, and they have quite significant roles there. Now, I want to enter into the slides, and as you probably have heard already in the introduction, 50 Hertz is one of these TSOs. Yeah? I normally say the TSO is the natural winner of the Energiewende. I would like to explain this a bit, why this is the case. So allow me a few words about the company 50 Hertz, that you get an impression for what company I'm working. And then I'll enter into the challenges already mentioned that we faced when switching our system to a system which is massively renewable based. Now this is Germany as a map, and you can see orange colored the area which is supplied by 50 Hertz. Now basically, some of you might have seen a similar map already in the past. It's the former DDR, so the former eastern part of Germany that we supply, with some exceptions, Berlin and Hamburg. So that's our control area. It's a quite big area. Here are some figures regarding the control area. So it's about 30% of the total surface, and we have a peak load of about 20% of Germany. And what's quite interesting is that we have, regarding the wind generation, about 40% of the wind generation of Germany installed in our control area. So we are 50 Hertz as a control area with most renewables installed, and especially the highest share of renewables compared to the load. Therefore, it's also for us the biggest challenge of the 4 TSOs to keep the system secure, system operation secure. And I think we managed quite well to do this in the past. And I will give you some insights, what challenges we solved and what challenges we still see, where we have to work at in the next years. Now, I already mentioned that the TSOs, that the business model as it was designed by politics, leads to very similar aims as the politics have in Germany. And I want to explain this based on the slide which shows the main tasks of TSOs in Germany. Now, on the one hand, there is this very obvious thing: we are transmission grid operator. That's probably every grid operator, grid owner. But we also have the role of the system operator. So, as some of you might know, that if we enter an unbundled world, there are different ways of organizing the roles and systems, and there are many countries which have chosen to separate the role of the asset owner during the maintenance of the grid and the system operation. And then founding, for example, ISOs like in the US. Now in Germany we decided not to do this. And as I've explained, I think this is a quite good idea if you are in a phase where the system is changing massively and where actually these contradictional interests of system operation and asset-based extension are combined within one company. So we won't just say, as I explained, renewables overall. We will always have in mind, will be able to operate the system in a secure way. So I think this combined role, system, operation and asset ownership is, I think, a good solution if unbundled TSOs are introduced. Now we have another role, which here is called trustee for the renewable energy sources. So basically, now if you come into an unbundled world, the question is who is doing all the financial stuff, who is collecting the money, who is taking the risk if, for example, the renewable surcharge was not calculated correct, if more wind is blowing than expected, if more or less sun is shining. And that's also in Germany the TSOs that got that role. Again, that could have been decided different, but it's also not so clear who would be the natural entity for this if it's not the TSO. So we think we are quite well prepared for this, and we also think we fulfill this task quite well. Although this leads to a bit strange situation, I didn't explain it on that slide. If you look down here, that our main turnover is actually caused by this trustee process for renewables. Yeah. So our grid operation is only about 10% of our turnover. So we are, at least on the balance sheet, this is a very important thing. And of course, it's also changing the way the company behaves a bit. But still, we are proud to have that role. And as I mentioned, we think we fill it out quite well. Now that's TSO's task in Germany in general, and as I mentioned, I think quite important for developing solutions for the challenges and bringing the TSO into a role as being partner of politics when finding solutions. And also I must say, I'm now head of the department Energy Economics. Such a department didn't even exist at a TSO 5 or 10 years ago. So this also shows how also we are setting up ourselves to support this process and fulfill our role in an optimal way. The next slide here is now describing what actually the Energiewende in Germany is about. And I think it's quite interesting to see that it's not only about electricity. There are several aims that were set up by politics. Of course, one could ask, is that really useful to make so many aims? And there's also discussion in Germany if it would be better to just say we are only focusing on CO2 reduction and we don't care how this is done. So this was really a serious discussion. Now we decided not to do it this way. Why? Now basically there were several analyses made in Germany looking at the different options. Nuclear, one, okay, no public acceptance, it would be no option for Germany. We also, our experts also, scientists looked at the CCS, the carbon capture and storage option, which would be quite interesting for Germany as we have lignite as a natural primary resource, very cheap. So, carbon capture and storage, from a technical point of view, would be a quite interesting option for Germany. And of course, we had the option heading for renewables. And the analysis showed that there is no clear best solution in the long term, and that it's highly unstable depending on political decisions of countries. That means probably if the major industry countries would now or would have jumped 5 years ago on carbon capture and storage, this solution would have been the cheapest. Now in case political decision makers jump on renewables, renewables have the chance to be the cheapest. So it's not that there is a optimal solution we can head for, but it's rather something that we can influence by our own decisions. Which solution becomes the cheapest? And based on this knowledge, Germany said, okay, we want to head for renewables and try to make it the cheapest solution for the world for CO2 reduction. And I think we were quite successful with that. And as it was already mentioned before, I think the world partly at least benefits from our investments that we did, especially in the area of photovoltaics. Now, we still have here the aims for the share of renewables in the electricity sector on the slide deck, and I want also to read these values. So it's 35% 2020, at least 35%, and 80% for 2050 in the electrical system. Yeah, and the nuclear phase out, yes, as I mentioned, maybe it was too fast, or it was very fast, causing also severe problems, completely independent from renewables, because the nuclear power plants were located in Germany right next to the load centers, yeah? And switching them off causes severe problems. But we will also overcome that. That was a political decision, and the phase out here till 2022. No nuclear units shall be at the grid anymore. Well, these are the main aims. Now, looking at our historical past, what has changed, and I think there was also presented before a similar slide, you can see that we are quite well on track regarding the aim of reaching the 35% of renewables in the electricity system until 2020. Currently, we are at about 25%. This last bar here is from 2012. So 2013, it was already about 25%. So my current expectation is, yes, we'll do it. We will reach our aim of the 35%. And yes, we'll also do it and reach our aim to switch off all nuclear generators until 2022. But this is still quite hard way to do this. We have to invest in grid and other things to be capable, but we'll head for it, and we are positive to reach that aim. Here's a view on the expected renewable extension in Germany. So this is the installed capacity, and you can see it continues to increase. Also with the new legislation, I will talk about this later on. I think one important question that is raised internationally are the costs of the Energiewende and the costs for renewables. And of course, this is a topic, as the costs were quite high and the costs are quite high for renewables. And what I've shown here is the gross costs of renewables in Germany, of the different technologies, and all these lines add up to the sum. And what you can see is that looking at 2015, 14, we are still in a phase where the costs increase. Now, how does that come? Now, basically, we have a system in Germany which is quite similar to the system that you have in Japan with the feed-in tariff. That's what we used to have. And we guarantee the tariff for 20 years. And we had a phase 3-4 years ago where we had a massive extension of photovoltaic. And we had about 7.5 gigawatts 2 or 3 years in a row, with basically also a quite high feed-in tariff. And this capacity has to be paid now. So the decision is already done. It's sunk costs that we have here at PV. So this is why these lines are still rising, because we have to pay it anyway, and every additional capacity that we build up, of course, costs new money. But this view is not, I think, the most relevant one, because these gross costs don't take into account that the units produce energy that has value. And therefore, I have this next slide, what includes the value of the energy. And value of energy here means what do we get out of the energy market. And with energy market, we mean the marginal price of the system. As I've learned that there is no energy price transparent in Japan. So the marginal system price, that's the price where we can sell the energy for, and in a market, in a free market, and this is here the red line. So basically what we have to cover with our renewable surcharge is the difference between the costs for the renewable energy sources and the income we get from selling the energy. And you can see that also this value will rise in the next years, as long as the very expensive units are still in the system. But then we reach a point where these expensive units step out, and the difference between these two curves gets lower. So it means the renewable surcharge, which actually covers this difference, will not rise to completely crazy values, but it's already quite high, and will rise still a bit and then go down again. And this is also important for politics, that we are not running in a way which we can't head for in the long term. So this is a very important thing that we see. Yes, it will again drop the renewable surcharge below values we currently see today in about 10 years. There were also discussions to overcome this with credits. So far, there was no decision on that. So we really try to suffer the next 10 years and then benefit from the system. Next slide is showing the renewable process with the role of the TSO. I think I'll skip this. It's quite far away actually from how your system works, because the utility has all the roles. Now, of course, if you start separating roles, you have to define who does what. Yeah? Maybe very few words on this. As I mentioned, we have the financial process of the renewable energy system in Germany, and we are also responsible for bringing the energy into the market that is compensated via feed and tariff. So these are the two important roles for the TSO in Germany, and this is done via a quite complex system. I don't want to go into detail here. I would like to jump now on the changes of the new legislation. Maybe some of you have heard that there was a new Renewable Energy Act in Germany decided on in August this year. And from my point of view, this is a result already of these expert groups working very closely together to really overcome the problems of the Energiewende. It were not really very popular decisions taken here, but it were important decisions to stabilize the system and not to leave the path towards a system with 80% renewables until 2050. So the target corridors were fixed for technologies. Again, something interesting, I think, because there are other countries who just say, okay, we don't care which renewables are built, we only want renewables. We say, no, we want special technologies. Now, what's the thinking behind this? It's the hope of further learning curves. And again, the attitude that we can steer by our decision the development in some manner. This decision was especially taken in the area of offshore wind, where we accept much higher feed-in tariffs or equivalents to feed-in tariffs that I wrote down here compared to onshore wind, hoping to see a big cost decrease in the next decade. Also interesting, the biomass topic, not very popular at all. Less than 100 megawatt per year only. That means there won't be any additional biomass. I think it was a very good decision. It's caused a lot of problems in Germany, and it has a big influence on society if agriculture structure is completely turned over by the demand of biomass. That's not the intention of the Energiewende. There were also some other changes. We introduced the direct marketing obligation for direct marketing for units above 500 kV. I think this is, even goes down to 100 kV. That means every wind generator will not be marketed by the TSO anymore in the future. But you have to look for a direct marketer. But with a system which is also quite sophisticated, I will say a few words about this later. There's another thing now, how we can bring down the feed-in tariffs or the equivalent of feed-in tariffs. And there was the idea to introduce auctions in Germany, and this shall be tested. That's also a decision in the new legislation. And there's one third thing, which is also, I think, very important on the slide, that we headed for a very complex topic, the self-production of electricity. Now, in households, this is quite nice. If houses produce their own energy, it doesn't disturb the system too much. But if industry really gets incentives to build up their own generation units, which are less efficient than the central ones, and then causing a system cost increase, this can't be accepted anymore. And therefore, the decision was taken to introduce a RES surcharge on self-production. Also, a very unpopular decision, but it was taken, and we entered that the only path that leads to efficient system in the midterm. So there were important decisions that were taken. Every single one doesn't look very big, but I think it was really a good result out of very well done impact assessments that we had in the last years. Now I want to talk about the three key challenges. And the first one is to minimize costs for new renewable energy sources. And one very central element is there, the introduction of the floating market premium. Now, I've understood that this thinking is quite far away from actually what is currently in Japan, because an important basis to introduce such a system is that you have a transparent marginal system costs, which we see as a price of the power exchange as a day-ahead price. So that price is not available in Japan. So there are a lot of challenges that have to be overcome to introduce such a system. But I think it's really worse when talking about massive penetration of renewables in the midterm. To think about such a model to avoid that a central entity like, for example, the TSO does the marketing of renewables all the time. I must say I don't want to go into detail here because time is running, I think. But in case it is an example with numbers that you can see on the slide. I think if you look at it carefully, you probably can understand it. Otherwise, I'm also very happy to explain it to you after my presentation or in the evening event. This floating market premium model is also before the decision about a mandatory direct marketing got quite popular in Germany. And this is shown now in these two slides, especially for the wind production. About 85% of the wind production was already in direct marketing based on this floating market premium model before the new legislation began. So it's not only the solution for the new renewables, but it was also an optional solution which was chosen by 85% of the renewable generation that are existing today. So basically, for the wind, this is a model we currently use. For solar, it's a bit different, and it will stay a bit different. Now, direct marketing is a good thing if a direct marketer can negotiate with a wind park to get data, to decide of intelligent usage of the windmills, for example, to provide control power. But if you look at the 3 or 5 or 8 kV PV systems on household roofs, the situation is a bit different. There, it doesn't make sense that a direct marketer invests in getting data. The value is just far too low. And therefore, you see the situation that all these units are still marketed by the TSOs. That's the orange curve, so it's about 85% still marketed by the TSOs with a fixed feed-in tariff system. And these 15%, the remaining 15%, are these large-scale PV systems. We sometimes have 30 megawatt PV systems outside of the towns. These are direct marketed, but all the small units, they stay with the TSOs. And as you have seen the values before, 100 kV, that's too big for any roof. So this will stay like this in the next years. Probably for the whole decade. Now I want to summarize the results for this first key challenge. What were the main lessons that we have learned? It's in case of large renewable systems, actually the costs of marketing by the TSOs and in direct marketing, they're pretty similar. But with the mandatory direct marketing, we took the next step to also introduce the renewables into other services, like, for example, provision of control power or better market-based curtailment. So these were the main achievements. Otherwise, and before these are relevant, from my point of view, a fixed feed-in tariff is okay. It's a good solution, as you have it today. It just has to be parameterized correct. As I've understood, this is a challenge. In Japan, it was a challenge. In Germany, and solutions have been found. They were also presented in the last slide deck, how we adjust the values to meet our corridor, and this is working quite well. So it's a solvable issue. To minimize, another lesson learned, to minimize the costs of new renewable energy sources, we also understood that it doesn't really make sense to put very many risks on the investors in renewable energy sources. Now, other countries have done this in a different way. They have said the renewables have to be fully exposed to the energy prices. They have to finance themselves just like any conventional generation. And basically, as far as I know, nearly all of these systems have turned out to be much more expensive, at least for the customer. Even sometimes failed that there was no renewable investments seen, if then there was a price cap on the costs for renewables. So Germany stays with a similar risk profile for investors in renewables as we have in the feed-in tariff system, and believes it's the right decision to leave it like that. What interesting is that this was also not really a no-brainer. The utilities, they quite heavily pushed for higher risks for renewable investments. And I think this is also quite logic. Now, the utilities, they have really a problem as a conventional generation is not so profitable anymore. And if the share of renewables grow, they would also like to get a piece of the cake. But this doesn't work if the risk profile is different. So they tried to move the risk profile of renewables in a similar order as the risk profile of conventional generation, which of course would then give them much better opportunities for investments. But the politics resisted and said, no, we'll stay with that risk profile of the feed-in tariff system, but introducing direct marketing anyway. So I think this was also a good decision, avoiding cost explosion in Germany. What is our main cost reduction potential for new renewable energy sources then? It's probably that this feed-in tariff has to be prioritized, correct? Okay, we have these corridors. Still, we are not sure if this is the only instrument we should need. There's also for wind a correction factor based on the wind situation for each windmill to really get an appropriate financing for wind generators at the different places in Germany. So we are really trying to optimize the system in a way that the costs are minimum. And the next step is then the introduction of tendering, as I mentioned, which we will be testing in the next years. But this is also not so simple as it seems. As the question arises, who's carrying project development costs, and this can also be a driver for additional costs. And we very slowly tackle this issue to avoid any cost explosion here. So future challenges. What are they? Basically, it's quite interesting that the Germans, they don't really care about that high costs for renewables. Now I presented the values. I think you have seen them in yen. I've mentioned them in euro. It's about 20 billion euro per year, maybe rising up to 25 billion euro per year. But the Germans think, yes, it's a good investment. And this is quite commonly shared. There is no big opponents that someone says, what have we done? Why are we financing the learning curve for PV in a land where the sun is not shining so often? Really the people believe it was the right decision, and it is the right decision to stay on track. But what people don't want is that our industry is suffering from this. And this is our main concern, and the main concern of the people actually, that one wants to keep out the question of energy prices from industry politics. We don't want to have a system where the heavy industry using a lot of energy is moving from Germany to China, because they have no CO2 price and can produce energy cheap by coal. So we try to find a solution for a good cost distribution that avoids such effects of heavy industry moving out of the country. And I think we were quite successful. We still have some important aluminium producers in Germany. Before the Energiewende, they were thinking of leaving the country. Now they're happy with the very low energy prices that the renewables cost, and they don't have to pay any surcharge, so they are competitive. But it's still a challenge that we face, and I think the discussions in the area won't be over, especially as the European Commission is looking at this very tightly. That they say it can't be that you subsidize your industry by lower energy prices, by pushing into renewables into the market and taking out the costs for renewables for some customer groups. So it's not solved, but we made some very important steps forward. That about the big points there was now an agreement reached, with the new legislation with the European Commission that we can do it approximately in the way we did it before, and that these rules will apply all over Europe, so every country is allowed in Europe to take out the renewable surcharge for specific industries. And the other question is how can market distortions due to the renewable surcharge, for example, by self-production, can be minimized? I already mentioned this was one important thing in the new legislation, that we introduced the renewable surcharge on self-production. Very unpopular, but there is no alternative. So we have to go this way and have to reach a point where the question if companies pay a surcharge doesn't depend on the self-production anymore, but only depends on the share of costs electricity causes, and according to the full cost of the company, and if it's in international competition. So, therefore, this is also something which we tackled. Still, it's not a final solution there. We did a first step. Next ones have to follow. So, let's see if we reach that, if we can overcome these issues and avoid misleading incentives. That's of course something that the politics don't want. Now I want to talk about the next key challenge, the balancing of the volatile generation and the load. I think this is maybe the problem that you come to at very first sight if you think about renewables. How can this be that such an unstable generation like PV and wind power supply a load with a constant demand? That's a very simple question, and of course that is a key challenge. I want to briefly talk about what are the challenges behind that on first sight. And therefore, I think it's quite important to look what actually happened when renewables expanded in the last years. And these are maps of Germany, and the red dots are windmills, wind farms, and the yellow dots are PV systems. And you can see over time what happened. Now, first there was that we placed windmills in northern Germany. Why? Mainly because the wind is blowing there. So it would be very inefficient to place windmills in southern Germany, although maybe additional transport capacity is needed. So if we have a fixed feed-in tariff system, then this is a logic result. You see the windmills where the wind is blowing, and it's social economic, the most efficient solution. With PV it's the same, but the other way around. In the south of Germany, the sun is shining more often. So you see, that's where the investments in solar took place. Now on the next slide, you can see what that meant for the electricity system in Germany. And here you can see how this changed over the years, and how the situation looks like today when a lot of wind is blowing. Now in former times, it's on the left side. It's 2012, so it's a bit away. There was already some production, but not so much yet for renewables. You see, that the production was mainly over here, was quite close to the load centers done. There was a peak in the very west, and a peak in the very east of Germany. That's a lignite generation, feeding a lot of power into the system. Now what happens, 2020, you see we have a lot of generation at the very north. That's mainly, of course, offshore and onshore wind. And if the sun is not really shining, of course, it's a lack of production in the south, and you see massive load flows. that cause the need for massive transport capacity. So basically what I want to say here is, if you talk about balancing, you're not only talking about an energy problem, you're also talking about a quite big transportation issue. Because it doesn't make sense to place renewables directly next to the load centers, and it doesn't make sense to make a local balancing. There was also some of the lessons we learned. Yeah. So you have to balance in very wide areas to minimize costs. Use all capacity that's available. And if you have a problem, due to very special weather conditions which occur every 5 or 10 years, then you need a good TSO, securing system also during that conditions. Now, this cannot only be seen by such a map where we only see the production and the load, but also by looking at our grid. This is the transmission grid of 50 Hertz. And here the lines are shown, and it's shown how the lines are loaded. And one picture from 2009 to 2000 and one from 2013. And you can see things have changed. Grid operation really got more difficult. We see that our system is really loaded at the limit, and the grid operator has to intervene in the system to avoid any disruptions. This, of course, means we need new IT tools, new processes, much more data, challenges. And we invested quite a lot. Also, international cooperation, very important. So there were really a lot of new processes set up in the last years to make this possible. Now the main reason why we see this actually is that grid investments were not as fast as the extension of renewables. And this is something we want to avoid in the future as good as possible. I will talk about this later, how we're planning to do this. But just to give you an impression, how strong or how complex system operation got in such a system. I presented here the energy amount of redispatch done by the TSO. Now maybe the word redispatch is not known in your market here. That means the TSO looks at the market results, at the dispatch of the market, and says, well, it might be efficient for generation, but for grid it doesn't fit. And then we say the generation units, please change your output. Some in the north, please lower your output. Some in the south, raise your output. And this is the energy that we shift. That's presented here. And you can see it's in the area between 2 and 4 terawatt hours, 2,000 to 4,000 gigawatt hours. It's quite a bit already. Still, it's compared to the total consumption in Germany of about 600 terawatt hours, of course, not really much. But it's complex, and we really it's more or less a daily business that we have here to get the system operation secure. It's a challenge, but as I mentioned, it's our business model to take the challenge, to develop the processes, and to make this possible. And we are very confident that we will manage to do this also in the future by a combination of better tools, better processes, and very important grid investments. This leads to my next point, grid investments. Now for a country like Germany, this is not very, we had nearly no grid investments in the transmission system over 1 or 2 decades. And now we suddenly notice, well, with the Energiewende, we need really, really big new investments. And therefore, a lot of analysis were done how we can achieve this. And the outcome was that we need new technology and we need new processes. And the new process is the federal requirement plan for grid extension. And the results are also shown here. It's that we say, okay, we need at least 3 big, massive new DC links connecting north and south. So far, we had no DC links in Germany, and I think it's also one of the very seldom situations in the world where they are directly next to a complex AC grid in operation. So it's also a new challenge to develop new rules, how these are integrated in system operation. But again, it's a challenge that can be solvable. It's good experts looking at all the problems and looking for solutions that can be found. To give you an impression, in our control area, these are all the grid extension plan projects that we are currently heading for, and you see it's quite a bit. So it's really happening something in the German transmission grid to get it strong enough for this further extension of renewables down all the way, and we look here in this case with our requirement plan 20 years ahead. So it's till 2035 now in the current round that we build a system, a transmission system that fulfills these tasks. Next important thing, and this is also something that is always under discussion, is the question: what role play storages? I mean, if you have a system with 100% renewables, it's pretty clear. The renewables are producing, and then you need storage during times where they don't produce. But the big question is, when do you really need a storage in a system? And there were quite intensive analysis made, and I would briefly want to share very few results, but I think the most important ones for German politics decision in the last years. And just that you understand the following graph, I explained here what we mean with the two terms here: short-term storage and long-term storage. Short-term storage means that's technologies that are only capable of storing energy up to maybe 4, 5, 6 hours, but with a quite high efficiency. Long-term storage means basically, as a technology, power to gas, low efficiency, but nearly unlimited potential regarding the energy amount that can be stored. And now analysis were done. What happens if we introduce storage in the system? As I mentioned, it's exemplary results, but I think they are really quite interesting. And with a system of 40% renewables in Germany, if we bring into the system at the left bar 15 gigawatts of a short-term storage, so something like batteries or maybe additional pump storage units, what happens? You see the lignite generation, it's a brown bar here, increases. And the gas power plants, they produce less energy. So more or less, the storages help flattening the profile for lignite generation. This is, of course, good for the companies operating lignite generation, but it's not so good if you look at the CO2 emissions. So basically, if we now would invest into storage in Germany, we would increase CO2 emissions. Now, in case the market would decide to do this, probably nobody would stop the market to invest in storages. But from the results, it got very clear that the German government will not subsidize storages in any way. So that was, I think, a quite clear decision that we made in the last years. That was under discussion, but this is not on the table anymore. Of course, these results, and it's a similar one for the long-term storage, it's even more lignite in the system, so even more CO2 emissions and even less gas production. Now, of course, this is not true for all times. If you take an 80% renewable share system, then of course storages are valuable. So it's no question that at some point of time these storages become relevant. Now, some of you might say, it's pretty clear that we see such results because Germany has so many interconnectors to the neighboring countries that allow balancing the renewables in other countries and reducing the problem. Now, also the makers of this study, they knew this concern. It's also in Germany quite viable because we don't know what the other countries do. So they said, okay, let's build a fence around Germany, and these results were calculated based on no exchange with other countries. So it's really a worst case or a scenario, or from storage perspective, a best case scenario, and still you see the results are very stable. So it's clear for the next decade, storage is not on the agenda for subsidies in Germany. Now, you can follow, we won't see any storages in Germany, and I would say this is not correct. You will see storages in the market, especially in the area of control power, primary control. That's in typical area where storages, batteries will play an important role. And also on household level, for home PV systems, batteries will play an important role, but not at the dispatching level for the complete system. Yeah, so I want to come to the lessons learned of that second key challenge. Now what's really a common view now in Germany is that, shared view of all relevant stakeholders is that grid extension is the most efficient, cheapest way for efficient balancing of the system. This was also not clear in the beginning, but this is now accepted. And of course, a good situation for the TSO. But it's not. But it's really an objective result. Yeah? So that's the nice thing about this here. To realize the grid extensions, we had to establish new processes, and in these new processes is a very, very important element: the public involvement. I didn't talk so much about this as time is running up. But in case anybody's interested here, I think there are really a lot of lessons learned how to do this and how to involve the public in a way that you really get grid extensions done. And the third lesson learned is that large storages are not needed, at least not until 2020, with a 40% share of renewables. And if we take into account interconnectors, the not so optimal scenario for storage, it's far beyond where actually storages will pay off from a system perspective. What are the main future challenges? Yeah, basically I said, okay, it's probably ensuring the security of supply, because the conventional generators are really suffering from the price decrease caused by the renewables, and we still have established a system that compensates this. And this is now under heavy discussion in Germany, how, or if we have to establish a system and how the system should look like. That's a key challenge that we will have to solve in the next 2-3 years. And the next one is further optimize redispatch process. We will not be able to build a grid that fulfills any needs of generation in case we have so fluctuating generation situations where some peaks only occur maybe only for a few hours a year. So we need really good processes to deal with this uncertainty. Now I want to enter a last key challenge, and that's the inaccurate forecasts of renewables. That means looking at the day-ahead market and the day-ahead time zone where the dispatching of conventional generation is done. You might have normally you have a quite good forecast that meets the actual feed-in. But there are some rare days where it's not the case. And here I've shown the worst case that we have seen in the last 3 years. So it's not an average. It's the worst days of the last 3 years. But there we had the situation that the day-ahead forecast of the PV in Germany was about 10 gigawatts higher than what we actually saw in reality. Now one could say, okay, we have to get better forecasts. I say, no, we don't. We have to have a system that is capable of reacting on this. And this means we have to be capable of activating a quite large amount of new generation within a very short time frame. Now in this case, the main new information we got was about at 8 o'clock in the morning when the sun was rising, and we suddenly noticed, there is some fog which didn't disappear as expected. And then we ran into the problem, but we had only about 2 hours time till that the difference of 10 gigawatt was summing up. So it really caused problems. Yeah, what are the solutions for that? And I think one very important thing is here to somehow at least create an option for generation to produce. I mean, in an integrated system, this is no question. But if you come to an unbundled market with independent power producers, then you have to have some kind of a coordination instrument which runs quite close to near time. And we call this intraday market, where we can physically trade energy now up to 45 minutes before physical execution. So that market then must be capable of showing really high prices. And this, of course, then should give the incentives in the system to react on this. Maybe also with a demand response very high, with very high costs, or by activating ancillary generators also with very high variable costs. So we will see, and this is okay also for us, probably prices in such special situations of several hundred euros per megawatt hours. But this is also very rare, and this must give the incentives for the flexible generation. So I want to come to my last slide. What's our lessons learned here? In an unbundled market, we must have some coordination of the generation and also possible demand response. And this coordination cannot only be done day ahead. Now, from a very first sight, you could say this is obvious, but it's quite interesting that there is no other market in Europe that has introduced such an intraday market as Germany has up to now. So it's still something where we say that is really an essential in market design, and something that can be a lesson learned by Germany. The future challenges are still there. Basically it means we have to somehow procure flexibility or have the flexibility in the market. This has basically two components. On the one hand, we are happy if we have an option of controlling renewable energy sources, and the best way from my point of view would be to see them in the control power markets. That's where we are currently working at. The other point is that, of course, also for the other way around, when the forecast is we have more renewables and it's less than expected, we have to have the flexible generation, maybe with very high variable costs, that is capable of closing the gap and ensuring system security. So these are the main challenges that I see in the sector here. I excluded that we need better weather forecasts. Of course, this is also good, but it's I think we have to mainly work at these points that I mentioned here. So thanks for giving me the patience and listening to my presentation. And I'm now very delighted if we can enter into discussion after the small break, I think. And if you have any questions to the slides, I would of course also be happy to answer your questions also in the break now.
Sengbusch. It was a very detailed description of the Energiewende in Germany, and I'm sure many of you might have many questions for Tomas Kåberger, Mr. Yamaka, as well as Dr. von Symbusch. I would like to ask you to fill out the question sheets that have been distributed to you, and we will gather them during the break, and we will make use of those questions during a panel discussion period. And during the panel discussion, we'll also have a discussion about the Japanese system changes from Dr. Takahashi. And we will have a 20-minute break, but before that, thank you very much, and have several round of applause for Dr. Fonseca.